right, so I'm Santiago Pericas-Geertsen. I'm the co-spec lead for JAX-RS 2.1 right now. I've been in JAX-RS for a few years now. And today I'm going to give you a quick update on this latest minor revision of JAX-RS and talk a little bit about the things that we're working on at the moment. Many of the things I'm going to be talking about today are very much under work. So really, some of the discussions are just even starting in the expert group. So it's all really bleeding edge stuff that we're going to be talking about today. So the three main big ticket items that we had for this minor release are rather important, I would say, and I'm just going to focus on those. There's a lot of little other things that we need to do for this release, but I'm just going to focus on the big topics. So the first one I'm going to talk about is some reactive extensions that we are building for the client API. I'm sure people have learned a lot about reactive at this and some other conferences recently, and it actually fits really well with the JAX-RS client API, and I think people are going to find that very useful. The other topic I'm going to talk about is ServerSent Events. This is something that we tried to add into JAX-RS in version 2 as well, but we sort of ran out of time. And I think it also fits rather nicely with the last topic I'm going to talk about, which is Nonblocking IO. All right, so let's start with some of the reactive extensions. Before I show you the new stuff, I like to talk a little bit about the old stuff, the things that we've added in JAX-RS 2, and in a sense, they're already old, and we think that there's a better way of doing things. So in JAX-RS 2.0, we added support for asynchronous processing, and this affected both the client side as well as the server side. So on the server side, what we did is we added a new annotation called @suspended and a new type called async response. And this is the way you basically indicated to the JAX-RS runtime that you wanted your resource method to be asynchronous and that perhaps the response to that request was going to come on a different thread. And essentially, the request thread could be freed and used for other things. A lot of people have asked why we've added those two things. Wasn't it sufficient to just add one of them? We'll see some examples. And the answer to that is that whenever you have a parameter in a resource method that doesn't have any annotation, then JAX-RS is going to think that's the entity. So we had a problem there. That's what we needed to add the @suspended annotation. The other thing we did is we extended the client API to support asynchronous processing. And at the time, we worked with whatever was available on the JDK, which was the future type. Many of you may have used that. And we've also added a new type that we felt was necessary at the time, which is called invocation callback. So let's take a quick look at a couple of examples that show how to use this. So the first one is future. And again, we're talking about the client API here. So the first part of the example is the normal bootstrapping code we have with JAX-RS client. The interesting part is what happens when you construct your request. So we added this notion of an invoker to the client API, and you could actually switch invokers along the way. So normally you would get the synchronous invoker, but if you want, you can switch to the async invoker, and then things will work a little bit differently. And you can see here in the async call highlighted in red, this essentially changes the overall type of the expression and goes from something that was supposed to be of type string to something that is going to be a future of string. So with that, you were able to quickly switch between different types of invoker. And in fact, we're going to see that we're going to continue exploring that extension when we go to reactive. But the problem with future is that it's not as powerful as we want to. The basic model with future is a polling model. So when you have a future, it denotes an asynchronous computation, and you need to check over time to see if the value that we're waiting for is available. And of course, we all know that polling is not the most efficient way of doing things, so it often happens that you just get tired of it, and then eventually you do a get, and you just request the value of that asynchronous computation. And of course, two things could happen. The value is available, and you get it right away, or you block, right? And so the whole thing that you were trying to avoid at the beginning, it's back in play here. So because of that shortcoming, we said, well, this may be sufficient for some applications, but other applications may prefer the alternative to polling, which is callbacks. And this is why we introduced the invocation callback mechanism. So with invocation callback, this is a JAX-RS specific type. What you do is when you specify the entity, first of all, you continue to use the async invoker, but when you specify the entity, you say, here's my invocation callback. Just let me know when the value is available. And of course, this may happen on a different thread and whatnot, but the idea is that you don't need to poll, you don't need to wait, and you don't need to block. And so the invocation callback has two methods, completed and failed, which are standard things we've seen in other APIs. At the time, this was not available on the JDK, so our only option was to add this. So this is obviously a step in the right direction. So now we don't have to poll and we don't have to block. But there's still a problem. The moment you start using more than one asynchronous computation and maybe start composing them or using anything that requires the value of one to be used in the other or wait for more than one, then the code becomes really messy. And let me show you the example. So here's an example of composition. You have two asynchronous requests, synchronous computations, if you will, more generally speaking, where the value of the first one is used as the input to the value to execute the second one. So we have an initial target one where we do a request. We set an invocation callback, and when we get the value, in this case a user, we take that, we put it in a header, and then we execute another request. And as you can see, this becomes less and less readable. For those of you that have experience with JavaScript, this is often referred to as the pyramid of doom, because you start programming and nesting these things to the point that it becomes impossible to read. So obviously, we need something a little bit better than this. And the aggregation use case is becoming more and more popular. So we really need to be able to execute multiple of these things and combine them in easy ways. So here's some of the use cases for asynchronous computations. The one I just showed you is composing two of them. You can combine two of them where you wait for the value of two or more of them and then execute a certain task. You can consume the value. If you have a collection of these things, you may want to wait for one of them or for all of them to complete and so on and so forth. Well, the good news is that the JDK has improved, and we now have better types to integrate into JAX-RS. And the way we can do that today is using CompletionStage. So this is in JDK 8, and which we depend on now. And anything that you see here, you're going to be able to run on JAX-RS 2.1. So again, we use the same extension point we had before, except we have a different modifier for that extension point. Instead of being async, it's Rx. And then once again, just like before, the type of the entire expression changes from just being a string to, in this case, being a completion stage string. Now, the good thing here is that we didn't have to reinvent the wheel. We didn't have to create new types. Once you get a completion stage, then you can use the API from the JDK to combine them and do whatever additional computations that you want. So this is, in essence, the same example I had in the previous slide, but hopefully much easier to read. So once we get the first completion stage, then we can compose that. And you see the .then compose invocation there. Even though composition is really a binary operator, the way it's expressed in the API is using methods. So we say cs1.then compose, and we create the other invocation in the same way we did before. And then we get a completion stage as a result. So in this sense, completion stage is a much more first order thing than what it used to be. And at the end, well, if you really want to print out the final value, then you wait on the CS2 to complete, and then you print the quote. So again, the API that the JDK provides is quite powerful. And all we have done is just give you the ability to obtain one of these types, and then you can just go and use that API. But it turns out that there are many other APIs that support this. One of the most popular one is RxJava. Some of you may have used it. So in addition to supporting completion stage from the JDK, we thought it was useful to provide an extension point so that you can plug other reactive APIs. And so this is the way you can do that, or you're going to be able to do that using JAX-RS 2.1. It's basically a two-step process. We really struggled to get this to be done in one step. We run into problems with generics, so we ended up doing this. Essentially, the first thing you need to do is you need to register a provider. This is the same registration mechanism we had in JAX-RS 2. And in this case, this is going to be a provider for an observable Rx invoker. And the whole purpose of that provider is to be able to create instances of this new invoker that we want to use. And again, this is going to be an extension. Not all JAX-RS implementations may support this. They all are required to support the completion stage mechanism, but this one is an extension that only some of them may support. And then the other thing you need to do is when you use the Rx method, then you need to specify what is the invoker that you want to use, essentially the one that needs to be instantiated through that provider. And then once again, the type of the expression turns into whatever type that library supports. In the case of RxJava, it's called an observable. And then once you get an observable, then you're on their API. And you can use, in this case, subscribe to print the final value. So we don't know which APIs are going to be supported, which libraries are going to be supported, but clearly RxJava is one of the main ones, so it's very likely that your JAX-RS implementation will support this extension. All right, so this is a summary. Oh, this is wrong, so let me skip that. So the next topic I want to talk about is ServerSent Events. So as I said, this is something we wanted to add to JAX-RS 2, and we basically ran out of time. So let me give a quick introduction to ServerSent Events. I'm assuming most of you, is anyone not familiar with ServerSent Events? Okay, all right. So ServerSent Events, it's a very rather simple specification. Originally, that was part of the HTML5 umbrella of specifications from the W3C. And the nice thing about ServerSent Events is that it's a completely HTTP-based protocol. And the sort of less desirable feature of it is only a one-way server-to-client messaging protocol. So if you used WebSockets before, this is sort of a one-way or single duplex WebSockets. And there are some other limitations. It's only text-based and things like that. But it's actually very useful. If you look at a lot of the new applications out there, a lot of them are exposing remote events through SSC. So it's actually very convenient to use. And the way this all works is there's a special media type defined by that specification called text event stream. And because we already have a mechanism in JAX-RS to do content negotiation and all that, then we can use that media type and essentially provide support for it. So let's start with the client API. Again, there's a client and a server component. What I'm going to talk about today is actually in the JAX-RS EDR, JAX-RS 2.1 EDR that you can go and get from the JCP. We've actually already made some changes to this. I'm just showing the version that it's out in public because the other changes are still sort of internal. But I'll talk towards the end of the presentation why we made some changes to this, and it relates to the ideas behind non-blocking IO. Okay, so for the client API, there's a new type called an SSC event source. And this, you can think of this as something that you use to create an SSC connection. So you specify a target to it and you build it, so there's a builder pattern there. And once you get there, then you can subscribe to that source. So you should think of this source as being a publisher, and this is where the connection comes later on. And so anytime you get an event, then your handler for that subscriber is going to be called. In this case, it's the print line method. And you can react to events that are coming from the server. So remember, this is just a server-to-client communication. So the client in this case cannot send messages to the server. It can only receive. So in this example, we're just sleeping for a little while so that we can get some messages. It's not really important. The other thing to notice is that the SSC event source is an auto-closable type, and that's why we use the try with resources statement. All right, so I think this is pretty straightforward, and you can do SSC without having to go to the low-level HTTP API. All right, so what about the server-side API? Things are a little bit more interesting here. So obviously, we have an at producers for the new media type that we're handling. And we have a couple of new things that we can inject in our resource methods. The first one is called an SSC Event Sync, which is the dual of the source that we saw on the client. And the other one is just called SSC. So the SSC Event Sync represents the connection, the HTTP connection. And the SSC is sort of a context object that we use to create the events. In this particular example, what we're doing is we're using an executor to start another thread. And in that thread, we send a couple of messages, and then we just close the connection. The SSC injection here is necessary to create the events. And we're showing a very simple example where we're just adding some data to the event. But there are other things you can do in an SSC event. You can look at the protocol. And there's 3 or 4 different kinds of messages that you can send. All right, so I think this is also pretty straightforward. But there's another use case that is also very important for SSC, and the one that you're going to be finding in practice most of the time, which is broadcasting. So what if you have multiple clients that want to connect to the same resource, and you want to send message? When you send the message, you want to send the message to all of them, okay? Right, so the first problem you're going to encounter doing that in JAX-RS is the fact that the default lifecycle for a JAX-RS resource class is request scope, which means that every time you get a new request, you get a new instance of that resource class. That may not be what you want in the case of broadcasting, so let's take a look at an example of how you could do that. And we're also going to introduce a couple of new things, in particular the SSC Broadcaster. So the first thing you do is you annotate your class with singleton so that you don't get multiple instances of this thing. And that way you can have a way of grouping all these client connections into what we call an SSC Broadcaster. So just like before, we inject, in this case in the constructor, we inject the SSC type so that we can create messages, but also create a broadcaster. The one interesting thing to notice here is that even though the lifecycle of SSC and SSC Broadcaster are managed by the JAX-RS runtime, the SSC and SSC sync are managed by the broadcaster. Let me say that again. By the JAX-RS runtime, the broadcaster is not managed by the runtime. So it's up to the application to create it and use it. And that's important. You'll see when you look at some of the examples. All right, so this is just a setup for our resource class. So let's see how we can actually use one of these broadcasters. So we have 2 resource methods here, one to subscribe and the other one to broadcast. The one to subscribe, the only thing we do is when we get a connection over that resource, then we essentially just push it to the broadcaster and we say, hey, here's a connection that you need to talk to. And we just send a welcome message, I guess. And so the broadcast is the one that when we send the message here, then that message is going to be forwarded to all the clients or all the syncs that are associated with that broadcaster. So it doesn't really matter that we're using a multi-part form data media type here. All that matters is that we're getting a string event, and we can use the broadcaster that we created to broadcast that message to all the clients. Mm-hmm. Why is the first one? Good question. Yeah, it's a typo. All right. I'm sorry. No. Did you say the second one or the first one? No, the first one, it produces that because it's producing, it's an SSC connection that you're getting there, right?
So what's coming from that thing is ServerSent Events.
Right.
So it's producing it.
Right. All right, so this is the summary for SSC event. I think I had a duplicated slide here. And you can see this was the summary for the other part. Anyways, we're going to skip the summaries. All right, we'll just go to the next topic. All right, so let me talk about the third. Any other questions since we had a question already? Any other questions about the SSC part?
So the broadcast could happen anywhere you have a reference to SSC?
Yeah, to the broadcaster, you need to have a reference to. Yeah. It can be. Yeah, this is just an example of somebody coming from the outside and pushing something that wants to be broadcasted. But normally, this will happen from the server itself, right? All right. So skipping the summary again, I had a mix-up there. Let's move on to the next topic, which is non-blocking IO. All right. So let me start with some motivation behind non-blocking IO. Well, the main motivation is that there are certain apps that need a little bit more control over the input-output. And we sort of had this idea was here from the beginning. We have, I think, Paul here from JAX-RS 1 who knows about this. We've added, since JAX-RS 1, we had this idea of streaming output that was a way of providing applications a little bit more control, sort of a lightweight message body writer. But it turns out that that's not sufficient for what these new breed of applications require, where you have a high throughput requirement on I/O. So we struggled with this idea of how to do non-blocking I/O with JAX-RS, and I'll show you a little bit where the discussion started and where we are at the moment. So first, before we move forward, as I said, let's have a look at what we had since JAX-RS 1. I don't know how many people have used this particular type called a streaming output, but the basic idea is that you could actually have an entity of type streaming output, either the way it's shown here in the example, or you can return it as part of your resource method. And all you had there is the ability to get access to the runtime, if you will, at the time the entity was going to be written. So at that time, you could, rather than using a message body writer in this case, you can just have full access to the underlying stream and write to it. Of course, as you can see in the example, this is an old-fashioned output stream. And in particular, it's going to be a blocking output stream. So you're going to get called just exactly once here, and you're going to be given the ability to write, but there's no guarantee that that write is going to be non-blocking. So even though this was something that people thought could be done, it really doesn't work for the non-blocking I/O. So based on this idea, the first proposal was to go something in this direction. So what if we had another type of streaming output, if you will? Obviously, at this time, we already had Lambda, so there was not a need to create another type. And the basic idea here is that this write handler is something that will be called multiple times. If you're familiar with the way Servlet does NIO, this is somewhat similar to that, by the JAX-RS runtime. And so every time you get called, you have a chance to write some data to the output stream. And then you also have the chance to indicate whether there's more data that you need to write or not. And so this was the initial thought about how we can do NIO in the context of JAX-RS, but there are a number of shortcomings with this proposal, and this is why we're moving away from it. In fact, some people have actually implemented this, extended JAX-RS to do this type of thing, but they quickly realized that there are some shortcomings as well. So these are some of the limitations. First of all, this operates at the level of byte streams. And we all know that if all we need to do is byte streams, we probably can use some other library. You know, JAX-RS is great for doing slightly higher level things, like operating at the level of POJs, for example. And that's why we have all this technology around message body readers and writers and whatnot. The other thing is that it was very difficult to see how this extension could integrate with the rest of the JAX-RS pipeline, especially with the additions to the JAX-RS 2.0 pipeline. So naturally, the readers, the writers, but also the interceptors and the filters. And finally, as more libraries are coming out and we started looking at what people were doing, we realized that this doesn't really integrate with anything. So unlike the reactive example that I showed you before, which was easily integratable with existing libraries, just doing this byte-oriented NIO thing did not fly. So the current proposal, and again, this is something that has started very recently, just a few weeks ago, is to go with the flows approach. So some of you may know that there is a type called flow. Unfortunately, it's in Java 9. And it's essentially a copy, I think it's an exact copy of what originally was part of reactive streams. The problem here, obviously, is that JAX-RS 2.1 cannot depend on Java 9. So we need to depend on Java 8. So we're going to have to jump through a few hoops in order to do this. We're going to have to create some additional types. But I'm not going to bore you with the details. I'm just going to talk as if we could run all this out of the box. And the advantage of using flows, as we're going to see in the next few slides, is that it's not just for bytes. I mean, you can certainly use bytes. You can use a byte array, a flow of byte arrays, for example. But it fits much nicer with the rest of the JAX-RS pipeline and how we do things in JAX-RS. And the other thing that is nice about it is that it provides the possibility to integrate with third-party libraries, just like we did in the reactive case. And I guess another great thing about it is that it's a very simple model to understand for the most part. So there's basically just three concepts, and these are patterns that we use all the time in computer science. So it's just an idea of putting them together more than anything else. So the first one is the concept of a publisher. And the publisher is something that can produce something, and we'll see that something can be different things. We also have a subscriber, which is sort of the consumer for whatever the publisher produces. And finally, we have a processor, and the processor is going to basically act both as a publisher and a subscriber. And of course, this is a really nice model because it's very composable. If I take the processor and I put it right after the publisher, then what I get is basically a new publisher, right? And if I take the processor and I put it right in front of a subscriber, then I get essentially a subscriber. So it's easy to build these pipelines and these flows. In terms of entity relationships, as I said, a processor is both a publisher and a subscriber, and naturally, a publisher can have 0 or more subscribers. All right, so this is all great. How does it relate to JAX-RS, if it does at all? So let's try to see if we can connect the dots here. Obviously, NIO is usually something that takes a little bit more work to get right. And so it may not be for all the use cases that you have today, but it's certainly for some use cases, and this is what we're trying to identify as part of this process. In particular, we believe it's beneficial for large payloads, and the rationale for that is that the likelihood of blocking when you're reading or writing is much higher when you're writing a large payload, right? If your payload is very small, then maybe you're lucky and you can read it right away. So the idea behind this is that most of the large payloads that JAX-RS has been used for involve collections, right? So you have a collection of something, and that collection can grow, and if you need to read all that from the network, that may be time-consuming, and you may want to do it non-blockingly. So in terms of, or in flow terms, basically a collection of POJOs, you can think of that as being a publisher for POJOs, right? So whenever data is available on the network, then you read as much as you can. Once you get a POJO, then you push it through the pipeline. And you keep doing that for all the POJOs that you read. So essentially, you're creating more of a push model, but still within the JAX-RS model, as we shall see. All right, so how is this going to look from the API perspective? All right, so here's an example, one of the first examples we put together for processing a collection of POJOs. So we have a post, we consume application JSON. The entity here, it's called POJOs, of type publisher POJO. So this is a new thing that JAX-RS will need to support. And we're using the async mechanism that I mentioned at the beginning of the presentation, where we say, I will want to process this on a separate thread. And so we inject the response that we can then pass to whoever is going to be responsible for producing that. And then since in this simple example, all we're going to do is we're just going to subscribe a new subscriber for those POJOs, which is part of the application code. And anytime we get a new POJO, then we can process that POJO and do whatever we need to do with it. And finally, when we get informed that there are no more POJOs coming from the publisher, then we can use the response object to return the response and say, we're done. Yeah?
You don't need any extra annotation on the publisher argument?
No.
We don't need a context.
No. No, because that's the entity in this case.
I have a question.
Yeah.
What if you're not dealing with a massive JSON object that has multiple collections in it?
You have multiple, well, this is really, at this point, is really designed for one collection, one large collection. But that doesn't mean that you cannot do NIO in other ways, and I'll come back to that later. All right, so even this, what appears to be a simple example, there are a lot of hidden details here, and you may be asking, why is this all going to work, and how does it work? So as many of you are familiar, those that are familiar with JAX-RS are familiar with the notion of a message body reader. Message body reader is a way to turn a serialized POJO into an object that your application can operate on. But in this case, we're talking about a collection of those things. So how do we deserialize a collection? Well, we need something new in order to be able to process these collections. So one of the things that we've been discussing is the idea of introducing a new type of reader. This could be done in two different ways. It could either be a new type of reader, or it could be new functionality on the existing readers that you would need to implement if you want to do an I/O. I'm leaning more towards the latter, so we'll see how this goes. But obviously, processing a collection is not the same as processing a single object, so you need some additional help from the application to do that. And in the case of JSON and things like that, obviously, they're going to be provided out of the box. So we need to know how to process a collection of pages, and everything I just said obviously applies to the message body writers as well, because you can do NIO writing, not just reading. So let's have a look at an example of that. So remember before that I said that a processor was something that was both a publisher and a subscriber. So you could have a resource method that takes publisher, think of it as taking a stream of pages and returns a transformed stream of those pages, just to make it really, really simple. So here we have a JAX-RS method that not only takes an entity of type publisher pojo, but it also returns one. And that may be confusing at first, because what does it mean to return a publisher? Well, in this case, what we're doing is the application is creating its own processor. I'm not going to show you the code of my processor because I don't even know what it does. But all we need to do is we can subscribe to the entity, which is called pojos, using our processor. And because our processor is also a publisher, then we can just return it as the value of the resource method. So basically what you're doing is you're sending a stream of pojos, doing some transformation on them, and getting them back. But you're doing this all using NIO, because the system is going to guarantee that it's all done through NIO. Any questions on this? I know it takes a little bit. Now this may seem related to SSC. We looked at the sync in SSC, and I want to come back to this example when we talk about SSC. All right, and so the other thing that this was going to promise us, as I said at the beginning, is the idea of integrating with other libraries. And I honestly didn't find a good library, so I just made up one here. So don't look it up because it doesn't exist. But let's assume that you have a library, a database library that knows how to do, how to return a publisher for objects that you're querying from that library, which is perfectly reasonable to think about. So the integration is provided at the level of that flow API. So let's say you do a get in this case, and you specify a predicate. So you run one of these database queries, and that returns a publisher, a pojo, right? So those pojos are going to be pushed from the database to the network in an NIO fashion. Of course, there's a lot of magic that happens behind the scenes here. The JAX-RS runtime needs to subscribe to the publisher that you return, and the initiation of that pushing needs to be synchronized. There's a lot of little details that we're still working on. But at least you can get the basic idea that as long as you have a library that does flows, you're going to be able to integrate with JAX-RS. All right, so another thing I mentioned at the beginning was what about the rest of the JAX-RS pipeline? JAX-RS is not just about resource methods. We have filters, we have interceptors, readers and writers and whatnot. So the answer to that is we're still working on what's the best way to do this. But think of a filter in JAX-RS. A filter looks a lot like a processor, right? It's something that sits in between the flow of data and does some transformation on it. The interceptor is somewhat similar, but it's more of a typed filter. It's really related to the entity and notes about the type of the entity that you're dealing with. So just like in the case of the readers and the writers, we have a couple of options. The first one is to add some new methods to these things for the NIO case. And the other is to create a whole new type and a whole new pipeline for NIO, which seems like a lot of work and a lot of new types, which is probably not the direction in which we're going to be going. So the discussion is still ongoing around how to do this, but there will be support for NIO at the level of filters and interceptors. And whatever support we come up with here, it's going to probably have an impact on this idea of the NIO body reader and NIO body writer. It's likely going to have an impact on the way those are defined. All right, so far I've talked about the server API, but naturally we can also do this at the client API level. We also want to do NIO there. So it's basically what you would imagine. We're going to do essentially the same things we've done for other things in JAX-RS. One of the nice things about the JAX-RS client API is that you can reuse certain things that you build for the server. So you may want to reuse a message reader, a writer, an intercept, and things like that. because the client library also supports many of those concepts. So the idea here is exactly the same. We're going to try to use the NIO body readers and writers on the client API if you so desire. And of course, we're going to need a new invoker. That's what we seem to be doing all the time these days. So the way to do NIO on the client API, at least the way we're thinking now, is as shown in this example. So just like before, you can ignore all the noise and look at the NIO modifier there. And that returns, that's once again going to change the type of the expression to an NIO type, which in our case is going to be a publisher. And I'll talk a little bit about naming later on. And then once you get one of those objects, then you can just use the normal Flow API. You can subscribe to them, and you're going to be able to read POJOs out of that connection. And of course, JAX-RS is going to guarantee that everything is going to be done non-blockingly. All right, so talking about vocabulary, and this is sort of a sore topic at the moment. I have been using publisher and subscriber simply because I think most of you are familiar with those concepts. But we may have to use different names. You may have noticed that I already use different names in the context of SSC. And the reason for this is because since we cannot depend on Java 9, we have to have some support inside JAX-RS for the Java 8 users. Maybe in the future there's going to be a new version of JAX-RS that is going to say, forget about all this, just run on Java 9. But at this moment, we can't do that. But the other interesting thing about this is that once we look closely at the way we could do NIO, we realized that, well, but this rings a bell here. What we're doing here looks very similar to SSC. In the SSC case, if you remember, we're actually injecting a sync into the method. But an alternative to that is to return a publisher. You don't have to inject a sync. You can also return a publisher. So in fact, you can think of the SSC case as being a special case of the NIO Flow API. Doesn't necessarily going to guarantee the NIO part. We haven't really talked about that. But from the API perspective, it certainly looks very similar. So this is what I said at the beginning, that even though the EDR is out and we have an API for SSC, we think it's going to change because we think a flow is nothing more, or an SSC connection is nothing more of a flow of SSC messages. So we're going to go back to that. We're going to look at how we're going to name these things. Obviously, we can take a copy of the flow type from Java 9 and put it in JAX-RS, but that's probably going to be very confusing. So this is why we're thinking about some minor rename, at least for this particular version. All right. Finally, a summary that I think it's correct. So for the I/O part, the direction that we're going is based on flows. I mean, there are some limitations. You brought one up about, what if I have more than one collection? But flows allows you to do not just publisher of POJO, you can do publisher of byte array or some other thing. Of course, that's not the biggest solution, but the point is that you're not going to be limited to POJOs. If you want to do byte processing, you're going to be able to do as well. We need the ability to do readers and writers for these collections. We're still trying to figure out how that fits in the rest of the system. One of the biggest problems we have is because we talk about integration with third-party libraries and all that, and of course all that relies on using the same types. If I use a different flow than the other library, then integration is a problem. So unfortunately, the solution for JAX-RS 2.1 may be just some adapters that are provided out of the box that you can use to convert types that are essentially the same type. And as I said before, maybe there's going to be a JAX-RS 2.2 or something like that, which will say, forget about Java 8. We'll go into Java 9 and just use whatever's there. All right, I already mentioned that. OK, so just to conclude the presentation, we're working on the public release. We're looking for feedback, so you can subscribe to the JAX-RS user alias. All the communication among the experts, it's going to the user alias as well, so you can certainly comment on them. And as I said, even though the EDR is out and there's an API there for SSC, it's very likely to change based on the latest findings that we have on the Flow API. All right, and I think I finished early for a change.
Is there a thought about providing filters for subscribers for SSE? So
Yeah.
So implementing two things there, could I have one and say, oh, but only simply the ones is without the
Yeah, I think if we're going into this idea of SSC being a special case of flows, you're going to get that. So no worries.
So once upon a time when I wrote a message body reader, I had trouble composing that.
Okay.
Is that still a problem?
Have you considered using an interceptor?
No,
Or it didn't? Okay. Do you know what an interceptor is? Vaguely.
once I can point that.
Well, you know what an interceptor is in CDI. Yeah, so you have a method, you say, I want to intercept the call to this method, and anytime somebody calls that method, you get called, right? And you have a chance to do something either before the method is called or even after the method has returned. So you're basically a wrapper on that method. Okay, so an interceptor in JAX-RS is essentially the same thing for a message body reader or a message body writer. So it's an around read to interceptor and around, or read from rather, and around write to interceptor. So perhaps what you're saying, composition could be done with an interceptor, and then all you need to do is just register that interceptor.
Okay.
Right.
Never thought of that as being a solution. Thank you.
Yeah. Yep.
I heard in another talk yesterday that SSE support in the browser is there for some, but not for some others. Was notably IE, Edge, not having that. That would put a pretty big damper on that whole idea if you don't know that all your clients are using Jersey client or some.
Right,
SSE.
right. Yeah, I believe that's true. I believe there are other things that are not in IE. Am I mistaken? Yeah, I don't really have a good answer. You need to talk to Microsoft, I guess, as to why they decided to leave it out. We have seen a lot of examples where you actually want to do SSC from your own Java applications. So to give you a concrete example, CAS systems, containers as a service systems like Kubernetes and Marathon and all those, they often expose an SSC event stream. So if you're doing anything with those things, you're going to be able to open connections and listen, which before you could do, but you had to open like an HTTP connection and then parse each event inside, look for the colon and whatnot, and it's going to be much easier to do it with this API. As far as the browser support, yeah, don't use IE.
I'm not using it, but
I don't know any. Yeah. Any other questions?
Can we ask like general
Sure.
JAX-RS questions?
Of course.
So if I computed the response already, but I need to do something else, but it's not related to the response, what's the recommended way of doing that in JAX-RS?
Okay. So you have a synchronous response that you want to return.
Yeah, you could say that part, but let's say I need to write a bunch of data to some NoSQL data store that isn't part of the response body anymore.
Okay. And you cannot do that before returning from the
Well,
yours.
I don't want to block the. I'm done. I need to respond, but I'm not completely done. I mean, I need to do some cleanup. I could actually give them the response already, but
Right. Right.
maybe some statistics need to be captured that are not actually part of the response.
Right. I don't know. I can't think of anything that you can use from JAX-RS. I suppose you can use things from Java, right? You can create another thread and.
Another thread pool to handle.
Right, to handle those cases, yeah. With the async case, one of the things you can do, if you define, if you use the async response pattern, then the JAX-RS runtime immediately knows that you're going to be processing the response in a different thread. So it's going to essentially, once you return, it's going to free the thread, the request thread, right? And then you can do whatever work you want on that. And if there is a response that happens later, I don't think this is your use case, but if there was, then you can respond from the other thread. This is why async was introduced.
Okay, I'll take a look into that to see if that actually.
If that may help. I mean, one of the issues that you have in certain containers, Java containers, is that you have a limited pool for server requests. So you don't want to start blocking all of them because you're going to run out of them, and then your server is going to start denying. Oh, is that what you're asking?
I mean,
So you should.
do it the right way.
So you should definitely look at the async then, because I think you're going to be able to do it that way.
Thanks.
All right. Yeah.
Yeah, the original integration with CDI.
Yeah, yeah.
Is that still in there?
Yeah, it's there.
Explain what that is, maybe in a little more detail.
Well, there are a lot of little areas where the integration with CDI was not great. I don't remember all of them, but there was one around constructors, for example, that wasn't great. And the biggest problem has always been the fact that JAX-RS is sort of multifaceted. It can run with CDI or without, and it can run in EE or outside. And it's very difficult to make it work in all the environments, even though we have a lot of conditional statements in the specification that basically say, if you're running here, then you do this. There are a couple of things that we want to do in CDI, but frankly, since we restarted, people know that we've been off a little bit on our schedule. We focus on these 3 items. We haven't had any discussions whatsoever on CDI yet.
Okay. But it's still planned?
It is planned, yes. We have CDI and we have a lot of other little things that we want to tackle, but once we finish these 3.
What is the overall timeline? Can you talk about this?
The current plan is to try to complete JAX-RS by July. Yeah, so it's a rather aggressive, yeah.
Especially if you haven't talked about CDI yet and you want to get that in.
Yeah, I don't think it's going to be a huge task, the things we want to do, because I don't know that we can fix all the problems related to CDI.
Released by July or just completed by July?
Well, I don't want to commit to it. Somewhere in July, yeah. Linda is here. She can talk about EE. I think the schedule that is published on the JCP site says September or October or something like that, but it hasn't been updated. We're really targeting July.
Along your slide, you mentioned interceptors.
Yes.
Is the interceptors among your this kind of binary atoms, the interceptors?
Can you?
Interceptors you can introduce.
No, the interceptors already exist from JAX-RS 2.
So you're not introducing.
We just need to make sure that they work with the NIO flow. Because all the interceptors and filters and everything we've introduced is they all have to do things with output streams and input streams, and they're all blocking, right? So if we want to do flows and we want to do things non-blockingly, I don't even know if that's a word, but I keep using it. Then we need to extend those things.
So are you going to do any CDI or
Well, there is integration with CDI already in JAX-RS 2. Yeah,
no, it's like support construct inject and such.
right.
As you mentioned, it's not going to be
No, it's not.
maybe the CDI being kind of support construct injection.
Yeah. And again, the reason for that is the fact that what I said before, that it's very difficult because JAX-RS needs to run without CDI. And in fact, if CDI had appeared before JAX-RS, or around the same time, we wouldn't have the at context thing and some of the other things we've introduced in JAX-RS simply because that was not on the platform. So at context is basically a way of injecting things in JAX-RS. And then the problem is that CDI appeared, and then we needed to align with CDI, but we needed to maintain backward compatibility, and things get messy.
Yeah, I understand that. It is like existed unit, and the problem I mentioned, JAX-RS unit, not as unit as the other units.
Yeah. Do you have a specific example? Is it the constructors that you tripped on?
Like some other Japanese spec thing, such as servlet, for example, because the Japanese component classes support construct injection. But for in the Japanese spec or JAX-RS, it says if the JAX-RS resource is CDI and you support the
That's right, yeah.
construct. So it's not in line with around other.
Yeah, and unfortunately, it's a very difficult problem. I wish we had nobody seems to have a good answer to do those 2 things: fully integrate with CDI and maintain backward compatibility. That's the main problem we have. All right, I guess that's it. Thank you.